Computer Lab's Gleason 3159 and Gleason 3149 contain high-power workstations used to design semiconductors. This process produces a lot of heat. The HVAC system in the room commonly breaks down, causing excessive heat to build up within the room. These high temperatures can interrupt computer processes and cause poor communicational performance and uncomfortable conditions for people who may be using the lab. Our solution is to install a system in each room that alerts the IT admin when the temperature or humidity of the room increases to an unacceptable level. This system uses a custom control hub and 2 custom satellite hubs within each room to communicate with RIT's Zabbix system, a network monitoring software.
Each control hub and satellite node is built around a custom PCB. This diagram shows which components on each circuit board interact with each other and how the boards interact. This diagram can also help with troubleshooting in the event of an error or malfunction with one of the components. After taking measurements throughout the room using commercial temperature and humidity sensors, it was found that the room temperature was relatively consistent throughout the room. We determined that it would be best to place the sensing satellite nodes in the northwest and southeast corners of each room, with the control hub being placed in the northeast corner near the door for accessibility.
The control board is responsible for receiving the values from the satellites, communicating with the client, and displaying the values in the room. It is powered through Power VNet, or PoE. It contains a power multiplexer to differentiate between USB-C power and PoE, a voltage regulator to lower the 5 volts to 3.3 volts, an Ethernet controller, an RP2040 microcontroller paired with flash memory, and a light sensor. An expansion port is also included for any modifications the client may want to make in the future. The satellite board measures the temperature and humidity data and sends the data back to the control hub. The autoboard sensor communicates with an I2C controller on the board, then sends the data back to the MEC controller on the control board. 2 connectors are included on each board, which allows multiple boards to be daisy chained together. The different satellite boards in a chain can be identified using the LED on the board.
Our software stack targets the microcontroller on the control hub and is written in Rust using the Embassy framework, chosen for its memory safety, modularity, and developer efficiency. The software handles network requests, reads sensor data, and writes to the screen. It interfaces with the Ethernet controller via SPI with interrupts enabling efficient frame processing. A stable MAC address is generated from the processor's unique ID, and the software supports DHCP, TCP, and UDP, with UDP facilitating SNMP communication with KCGOE's monitoring systems. The microcontroller's PIO subsystem offloads one-wire signaling to dedicated state machines, freeing the CPU for other tasks. The second SPI port drives a write-only display using a custom driver and library for text and graphics rendering, with the display's controller handling image persistence and LCD refreshing.
Before the conclusion of this semester, the modules will be installed in both labs. To minimize obtrusion to the design of the labs, the modules and wires will be placed in wire mold raceway end boxes, which are common in areas throughout RIT's buildings.